Hello and welcome to my iOS tutorials channel. I made a couple of videos in the past, but then I took a long break. But now I'm back with a renewed passion to create videos for y'all every single week. Today, we're gonna look at the natural language framework that Apple released around 1 year ago, and then they further compacted and simplified it in iOS 12. The main goals for this video is firstly to look at the ability of the framework to detect the language that the user has typed in. This can be super useful for supposed comments when you're able to detect if a comment is not in the user's native language, and then you can translate it to their language. Secondly, we'll look at the Lexical Processor. I will demonstrate how to count the number of words and sentences in a block of text. However, the processor also has the ability to detect the parts of speech of a sentence. Thirdly, we'll use the framework's ability to detect people and name locations. This can be super useful for specific apps that want to take specific actions based on if they're a person or a name location. One cool example would be if they detect it's a celebrity, they can pop up a detail view showing more info of that celebrity, or if it's a location, then they can show a guidebook on how to get there. Now we can go into the code and continue from there. Alright, so after you download the starter code, where I connected all the labels and text field inputs, we're going to first look into detecting the language the users typed in. So first we'll get the language code of the language the user typed in, and we'll do that using the NS linguistic tagger class and just check the dominant language for that text. I'm going to protect it with the guard statement. So this language code will return a 2-digit string representing the language. For example, for English will be EN, for Spanish will be ES, and for Dutch will be NL. And so we're going to want to convert that to a human readable text. And we can do that using the locale framework that has the current language of the user, and it'll process the localized string for that language code. We can set the appropriate label to that, and then we can check it out. So I'm going to run it and we can see how it looks. So let me type it in Dutch and let's see what comes up. See, it already detected Dutch, and now I'll type in some Spanish. It already detected it's Spanish. So now we'll move on to the lexical field. In this case, we're gonna detect the word tokens and the sentence tokens. So let's start off with the word tokenizer. And for this, I'll use the NL tokenizer class. And we have to choose a unit. The options are document, paragraph, sentence, and word. But in this case, we're gonna look for a word. After that, you have to set the language of the tokenizer, in our case English, and then you also have to set the text that the tokenizer is going to process. Using the tokenizer, we can get the tokens that we can then display the count of. So we do word tokenizer, it has a tokens function, and you just give it a string range, which in this case is our text start index using range syntax and the text.end index. After that, we can set the word count label to the word tokens count. We're gonna convert it to a string using quotation marks. There we go. I'm gonna copy and paste this for the sentences. The only thing that changes is the unit here. Everything else applies as well. I'm also gonna set the sentence label to the count. There we go. I'm gonna run it and we're gonna check that out. All right, so I'm gonna type how are you? Got 3 words, 1 sentence. Very good. Take 2 sentences and the appropriate number of words. Now we're gonna move on to the people and places detection. So for this, we're gonna use the NL tagger class, and we'll set it with a tag scheme of a name type, which can detect both people and places. After that, we need to set the tagger text that it's gonna process. So we do that like this. Now we can get tags using the tagger. So we do tagger.tags, and we choose the constructor that allows us to specify options. The range again is the text start index, range syntax. After that, the unit is gonna be a word because we're going word by word. The scheme is as we said above, name type. Now for options, we're gonna have multiple options. First, we're gonna remove punctuation, then we're gonna remove white space, then we're gonna remove other characters. And then we're gonna also join names. After that, we're gonna create a text to hold all the places and people detected. I'm gonna give it an initial value of empty, same with people detected. Initial value of empty. Now we can process through the tags we processed earlier. And I'm just going to use a switch statement to make things easier. Case, personal name, if it detects a name of a person. And then for that, we'll add it to the people detected list. And we'll have to type it to a string because we're getting the text using the range. And I'm going to add an empty space for readability. I'm going to do the same thing for the places name. People, then we add it to the places detected. Same thing, we need to type corset. And I'll add a space here, and then I need to add a default catch, and we'll break in that case. It looks like it is a place name, and we add it to that. Now we need to set the appropriate places detected list to the correct text, which will be places detected, and then the people detected list to the appropriate text. Now we can run this and see how it works. All right, so I'm gonna put Mark Cuban lives in Dallas, Texas. As you can see, we detected the place and the person over here, and you can have multiple people and places in a string of text and detect that as well. So hopefully you found this YouTube video useful, and if you have any questions, please comment below and I'll respond as soon as possible. All right, have a good one and take care.